of secant x is going to be secant x times tangent x, yes. Okay. So how should we go about doing this? How do we differentiate secant x, knowing that secant x is 1 over cosine x? How to differentiate 1 over cosine x? What should we do?
Minus sine x bracket negative 1.
Okay, if you want to do that, so you want to differentiate it as cosine x to the power negative 1. Then after that, use the power rule. Okay, then we get sine x over cosine square x. How do we proceed from here to get secant x times tangent x? Yeah. First step. Yeah, they say use this one. So secant x is equals to 1 over cosine x. Okay. Then how do we progress from sine x over cosine square x to what we want? Secant x times tangent x. Sorry? So we just split, right? Okay, so 1 over cosine x times sine x over cosine x, tangent x over cosine x. So therefore, we will get the required thing to show. Okay? Oh. Okay, so now in this case, when given that y is equals to x minus secant 2x, we want to find out what is the derivative. So since this is actually the part 2 of part 1, right? Okay. So that means slightly we have to be making use of what we know in part 1, right? So dy over dx. Okay, x differentiate, you will get 1, right? Then how do we differentiate secant 2x? How do we differentiate secant 2x? What do we get?
Go back to tangent.
Go back tangent. Who tells you that it's going to be equals to 1 over
Let
1 over cosine 2x?
x equals to 2x.
We already said, right, we need to make use of part 1,
Let
right?
x equals to 2x.
Let x equals to 2x.
How do you say?
Okay, okay, so let this be something, is it? Okay, that's a bit confusing. Is it necessary? Okay, we will use,
then it will become secant 2x tangent 2x.
yeah, so because secant, when differentiated, it becomes secant times tangent, right? Okay, so in this case, therefore, we do as per how we usually do for trigo. Okay, so that means secant will change to secant 2x tangent 2x. Right? Because when you differentiate sine, it becomes cosine, differentiate cosine, becomes negative sine. So when you differentiate secant, it will become secant times tangent. Right? So the angle remains the same, 2x, but don't forget we need to differentiate what's inside the brackets. So 2x itself needs to be differentiated and that will be equals to 2. Okay? You understand what I'm saying? No. Okay, so therefore in this case the derivative will be 1 minus 2 secant 2x times tangent 2x. And then after that, when x is equals to 3, what am I press into calculator and you will get 1.61. Make sure you press in radian mode. Okay. Then after that, in part 3, we are told that if x is increasing at a rate of 2 radians per second, we want to find the rate of change of y. So rate of change of y will refer to dy over dt. And what we're given is that dx over dt is equals to 2. Okay, so what are the two things that we need to multiply to get dy over dt? Remember our connected rates of change. So what would the two things be? Alexis? Dy over dt equals to what times what? What are the two things? Dy over dx.
Yes. Then dx.
Very good, dx over dt. Okay? So, therefore, in this case, dy over dt, dy over dx is something that we already have, and some more it is at x equals to 3, so their value is 1.6061. Multiplying with dx over dt, which is equals to 2. So therefore, we will get 3.213.
You skip place first.
Okay?
Whoa.
Okay, let's slowly also start to recall what we have learned last year. Okay, so progressively we start to do some recalling. Alright, so in question 22, okay, we want to show this identity. Okay, so should we start on the left hand side or should we start on the right hand side in this case? Do you think we should start on the left? Or how many of you think of starting from the right? Okay, I think it's up to personal preference. If you were to start from the left, what would you do? What do you think you could actually, what identities could you apply such that it will lead you towards tangent 3x? Sine and cosine. Then after that, it seems like
That's the formula. That's the
double
formula.
Double
Yeah.
angle.
double angle formula. Double angle, but this is 3x.
That's
2x plus x.
Oh, she just some right side.
So that's why, okay, in this case, this is 3x, alright, that we're trying to get. Okay, double angle isn't that straightforward for us. Okay, so it is somewhat easier if we start from the right hand side. Okay, 3x is equals to x plus 2x. So we use our addition formula instead. Okay.
So you do.
If you choose to right hand side, okay, so 3x is equals to 2x plus x. So using your addition formula, if you have forgotten, refer to your formula list. If you remember, then your brain is amazing because I don't remember. Okay, then after tangent 2x, you will use the double angle formula.
That's additional.
Yeah, so addition formula.
So
Yeah.
when you flip the x and the 2x,
Wait ah.
it's so confusing now.
What x and 2x?
Because the first tangent x and plus tangent 2x, why not tangent 2x? I know, but it is a bit confusing.
X plus 2x and 2x plus x. You're not comfortable with that.
Easier to memorize it in this form.
Whatever.
Okay.
Okay, so down here is the addition formula. And then after that, this part over here is your double angles.
Okay.
Okay, then after that we simplify. I skip this part over here, you just flip the fraction, divide by a fraction, so just flip, then your denominator will cancel out. Okay? So this is equals to left hand side.
So,
Yup.
what happened to the 2 tangent x?
What happened to?
The 2 tangent x in the denominator.
2 tangent x in the denominator.
Yeah.
This whole thing is here.
Oh, okay, okay. Oh.
Okay? Any questions?
So,
Yup. Yeah.
how come there got 2 tangent square x?
This one.
Yeah.
See?
Yes,
Oh, expand. Tangent x times 2 tangent x.
So, but then how come I got
Yeah. Then 1 minus tangent x and times 1.
Oh, okay.
Makes it denominator.
Wait,
Okay.
so,
I suggest you do the algebra yourself. Alright?
No, so
I didn't do every single step.
multiply the top only, right?
Huh? Now this one multiply 1 now. Make the whole thing same denominator.
So, put into one fraction. Maybe 2 tangent x bracket 1 minus tangent x, right?
2 tangent x
Bracket 1 minus tangent x.
bracket.
1 minus
No, this is separate. There's no brackets here. I'm not taking 1 minus tangent x to times this, you know. It's only tangent x that's multiplying this.
Oh, okay. Oh.
There's no brackets.
Oh, okay. Wow. This will come out answer.
It's a show question. Surely you will have to prove identities. Okay? Right? I suggest that you really work it out on your own, okay, rather than just trying to read my answers and try to understand. Okay? So when you work it out, then after you try to match how I get the steps. Right? Any questions? Okay. Part 2, we want to actually differentiate this fraction over here at x equals to pi over 3. So therefore it was necessary for us to show that it is equals to tangent 3x, because from there we will be able to differentiate easily. Okay? So I erase this part. Okay, so in order to differentiate what you're given, it is equivalent to differentiating tangent 3x. So this one we already know how to differentiate it. So that will be secant square 3x times 3. Okay. Then after that, when x is equals to 3, sorry, 5 over 3, sorry. Okay, your derivative that will be equals to 3. Okay? And press calculator. You know how to press, right? Okay, just press 3 over cosine square pi. Okay. Any questions? Yeah, 16.2, please submit it tomorrow. Okay, go and verify. Use the second